Hello everyone, I'm back with another interesting video in CCNA networking, that is IPv6 transition options. So in this slide we are going through with the IPv6 transitions, how it works and what's of their protocols. So let's start it. As we know, the IPv6 transition option, many transformation mechanisms have been processed for IPv6 transmissions options. But still we can say the number of devices uses IPv4, that's still in the large number. For some of these devices is not support IPv6. So the movement process is for any necessary from IVP and V4 and V6. So we have IPv4 V6, we have a dual stacks in each device. As you know, the dual stack, the word is a network that's configured with both IPv4 and IPv6 address, and anti-64 for create and mapping between the two address types. So let's understand in more briefly. IPv6 mechanism, we have transitions option as dual stack from IPv4 to V6 and vice versa V6 to V4. As we all know, the dual stack is a configured between IPv4 and IPv6, and later we IPv6 to IPv4 tunnel. We proceed further with the next step, that is a tunnel using between IPv6 by using IPv4, and the transitions IPv4 to V4 that comes with can be IPv4 or IPv6 to IPv4. So we can see in the diagram we have a dual stack, the combination or it's a configured with IPv4 and V6, and we have a tunnel that between the IPv4 using IPv6 and the translator, this IPv6 to IPv4. So this is the basic mechanism of IPv6. Next we have IPv6 routing protocol. So what is protocol? Protocol is a set of rules and regulations as predefined or as mutual understanding by both parties. As we know, the routing protocol is just like a IPv4. It's same we have in IPv6. In IPv6 that had been modified because for the using of the large IPv6 addresses, and the protocol is similar to IPv6. And IPv6 is a routing protocols having RIP-NG, EIGRP-NG and OSPF, and we have other more IPs just like ISIS and MPB BGB4. So let's start these terms. What we are having: RIP-NG, OSPF, EIGRP, ISIS, MP, BGP4. As we know, often in routing protocol IP being modified used for the IP for longer for IPv6 addresses. So we have different protocols in IPv6. Let's start with one by one. First we start with RIP-NG. It's a new generation or stand to be a new generation, or we can say RIP-NG is a distance vector algorithm for best route or path to reach our destinations, or we can say as definitions as in our screen, it's an interior gateway protocol which uses a distance vector algorithm to reach the destination. So this is RIP-NG. Next we have OSPF version 3, or we can say is a open shortest path first, which is similar to OSPF v2. It's find the fast path, how we can move our packet from source to destination. Or OSPF version 3 is a similar to v2. It's a concept, is a link to the state database, and is an external routing as in virtual path or links. So it finds the best path and gives the best result with that. Next we have EIGRP. It's advanced and distance vector routing protocol developed or using by Cisco. And OSPF, after that we have EIGRP. In EIGRP we can say it's an enhanced interior gateway routing protocol. It's advanced vector and developed by Cisco routers. So it's an automations of the routing and configuration of the protocols as an EIGRP. Next we have ISIS, or we can say ISIS is an intermediate system to intermediate system, or we can say is the routing information using an automated system, that's a AS, or said to be as autonomous system in our IP network. Or we have MPBGP4. As we know, it's a normal form of the border gateway protocol that we are using in IPv4, and which is the unicast. So these are the 4 to 5 of the different protocol with RIP-NG, OSPF, EIGRP, ISIS, and MP4BGP4. These are the IPv6 routing protocol. Next, we are going to configure how we can configure a router in IPv6. Same like IPv4, we have the Cisco routers. As we know, the Cisco router don't have IPv6 enabled by default. So it has to be enabled by the commands we are using on our command prompt, or we are using in our router. Or say, we need two things. First, we need to enable IPv4 to v6, and secondly, configure the IPv6 on it. And we are using the command IPv6 unicast-routing. And after entering in that mode, the configuration mode that comes with the int space gi 0/0. So we have to configure the IPv6 address like this: IPv6 address, and we have the IPv6 address 2001 OBB9 and ABABB. This is the form in hexadecimals. Then after that, we're using slash with the 64-bit systems, and EUI, that is 64. So this is the way we can configure the IPv6 in our router. Next, how to configure? Let's go with the proceed with advanced or more command. How we can configure with the v6. As you know, the below mentioned commands, we can see what we are using. We have a local IPv6 address has been automatically configured itself, or it's a linked local IP address that begin with the F, we can see in the picture, that begin with the FE80. As due to the MAC address interface, we having the MAC address like we mentioned here as a 00014265 and so on. That is calculated address is F0 to our MAC address. So the global IPv6 is being modified by EUI64 method. And here we configured our IPv6 in our router, and more we can go through with we can create IPv6 addresses to another router by entering the whole address, such as IPv6 address, and the IPv6 address is fully by entering it configure the IPv6 address on it. And we can also on the same subnet mask we can configure on the router by using the blue commands, just like png ping IPv6 and the IPv6 address, and it will give you the specific detail of the configuration. So after that, we are having RIP-NG, that's a routing information next generation protocol. As we know that it's a distance vector protocol algorithm. It finds the best route path to reach the destination. So how we are going to configure it in our router? To configuring a RIP-NG requires at least 2 steps. To enable RIP-NG using global configuration command in v6, or enable the routing protocol on the interface using IPv6. So we're having this command in our router, that's the IPv6 router space RIP-router1, and we configure the RIP-NG, that is the routing information protocol next generation. And we have another brief with that RIP-NG, and done with some configurations to the second router, and the second router will perform, say, giving some command just like IPv6 root. So it will display the options of the how we'll find the show the IPv6 root command, and we're using the RIP-NG. And later on we have a difference between nowadays we are using IPv6, but we're still having IPv4, and we are migrating to v6, but still system has not been configured with that, but the most of the majority is using the IPv4. So what they are, IPv4 and v6? As we know, IP is nothing, it's an internet protocol. It's a logical number, or it's the identification of machine, or they are just to identify the name of the machine with their IP address. So in network, we are trying to access the system, it has a IP address by its name that will convert it in IP. So The IPv4 and v6, we have a descriptions here. As we can see, the IPv4 is a 32-bit and IPv6 is a 128-bit. And IPv4, that's a 4 decimals. In IPv6 we have 8 group of 4 hexadigits, and the packet header is 20 byte long, and IPv6 is a 40 bytes long. Or we can say the configuration can be manual or through DHCP in IPv4, but in v6 it's an automatically off address. That's a major drawback I can see here. Or we have IPv4 v6 is IPv6 support. In IPv4 it's an optional, in IPv6 it's built in. So we have gone through with these sessions of the configurations of the in these sessions. So I hope you like this slide, and thank you for watching this video. See you next time, and stay tuned with more interesting video in CCNA chapter. Goodbye and have a nice day.